We are going to be talking about CSC2. We are starting with CSC2. It's this semester, and the topic for CSC2 title is object-oriented programming. And for object-oriented programming, we have various aspects that we are going to be dealing with. So to start with, we have to go to introduction to classes and objects. And under this, we are going to be talking about the objects and classes. We're going to be talking about object creation and destruction, accessing objects, classes, accessing class members, class specification, properties, class methods, types of methods, and inner classes. This is just an introduction to classes and objects. So let's go on. But before we go into introduction to classes and objects, we need to know what object-oriented programming is. We need to know why object-oriented programming. We need to know some things about object-oriented programming. So why object-oriented programming? What brought object-oriented programming? Actually, the first programming language that was used was the procedural programming approach. That was the first programming language that was used by programmers. But with this approach, there were various limitations that were involved with this approach. And that was why object-oriented programming was invented. And to start with, this procedural approach uses what we call procedural programming paradigm, and it involves so many factors. Like we have changes incorporated became a difficult thing, debugging became difficult, code could not be reused, then simplicity also was a problem. Now, what do we mean when we say changes incorporated? When a programmer needs to make changes, like for instance, you need to add a new variable or you need to change some functions, it became a problem in procedural programming approach. Then also debugging to correct error became a problem also. Then for code to be reused in procedural programming approach was a problem. You can't reuse the code. And the reason for this was because functions and data in procedural programming approach were separated. The method and the data in procedural programming approach were separated. It's not together like you have in object-oriented programming. Because in procedural approach, we notice that procedural approach are data driven. It's only action driven rather. It doesn't involve the data. But for object-oriented programming, the object-oriented programming involves both the data and the actions that will be performed on the data. So to overcome all these limitations, object-oriented programming needs to be invented. So that is why we are now talking of object-oriented programming. And for this object-oriented programming, we are going to be making use of Java. But we also have some other object-oriented programming languages. Like we have C#, we have C++, we have Ada. They are object-oriented programming languages. But for the sake of CSC208, we are going to be using Java as our programming language. Now, what are those things that are involved in object-oriented programming? For object-oriented programming, the introduction of object-oriented programming brought in some things, like we have data and methods that are being used together into a reusable blueprint. They can be used together, they can relate together. Then we also have what we call objects. and we also have what we call class in object-oriented programming. For these objects, we can have an example of, let me make use of an example of a car, for instance. A car can be an object. You can say a car is an object. Then for a car, we can have several attributes for a car. A car can have different characteristics, that we can have the number of a car, the color of a car, the manufacturer of a car. We can have all that. All those ones are the attributes of that car. Then let's assume you are a manufacturer and you need to manufacture, you need to keep manufacturing car. You don't have to start from the scratch if you want to manufacture a car. All you need to do is to have a particular blueprint, is to have a template that you have to use for the design of the car. And that template, that blueprint is the class. And that's why we said that for object-oriented programming, for you to design an object, for every new object, you need a class. And that class will tell us the attributes. It will tell us the attributes of that object. It will also tell us the behavior. That is talking about the actions, the methods of that object. Now, let's go on to the benefits of what are the things we can gain from object-oriented programming. Like we can have modularity. By now, we all know what we mean by modularity. This is one of the benefits of object-oriented programming. Modularity means breaking of program into simpler chunks, or you say simpler parts. Different when you have a complex program that can be broken into several parts, and that is what we call modularity. Then we have code reuse. Code reuse is when you can make use of a code over and over again. You can use the code over and over again. These are the benefits of object-oriented programming. Object-oriented programming involves programming using objects. It involves you using objects, like we have mentioned earlier on. And when we talk about object-oriented programming is a paradigm that can be used to design a program using classes and objects. And one other thing about object-oriented programming is that it helps programmers to create complex programs. It will help a programmer to create complex programs in such a way that you can group related data and functions. You can group them together. So this is one of the things that object-oriented programming would do. Then you need to take note of this, that when you are trying to solve a problem with object-oriented design, the first thing you need to identify is the objects. You need to identify the objects first. Then, because I've already told you that we are going to be using Java in this course, so I want you to take note that in Java, the mechanisms that allow you to combine data and the operations that will be performed on that data is the class. Into a single unit is what we call the class, and that will be leading us to objects and classes. So now, what are objects? What are classes? We are going to be talking about that. When we say object is an entity that encapsulates data. It will describe the states and the method through which it provides service to the outside world. What do we mean by that? For an object, objects are real world entities. They are what we can actually see, what we can actually feel, and they are things that have their own properties and their behavior. For instance, a human being can be an object. A car, like I told you earlier on, can be an object. Then you can have a student can be an object. For instance, you can be designing a student management system. And For this student management system, you can have the characteristics, or the attributes, or you say the properties or states of that object. And what are the characteristics or the attribute that you can have for this? You can have the student matric number, you can have the department of the student, you can have the courses offered by the student. So these are attributes of that object, and the object that we are talking about is the student. Then we can also have the bank account. For a bank account, for instance, you have the account number. Then you can also have the name of the account holder. You can also have if the account is a current account or a savings account. So that is that about the object, and that is why we said object is an instance of a class. Object is an instance of a class. So now that will lead us to what a class is. What do we call a class? A class is a user-defined data type, or you can also say a class is a blueprint of an object of the same kind, like the scenario of the car that I used earlier on. You can see that told us that if you're a manufacturer and you need to keep manufacturing different cars, you need a template, you need a design of that object, and the object in question is the car. So that blueprint of that object is what we call class, and that is why we say a class is a blueprint of an object, or is a template of an object of the same kind. So but you need to take note that in Java we have a car would have different entities. We have entities with different characteristics. It can have the attributes, or you say the properties, and it can have the behavior, or you say the method. For a class, the data in the classes are the attributes of that class. The data you have in that class, they are the attributes of that class. Then for a class also, the actions that are being performed by those objects are what we call the behavior of that class. The actions that are being performed, they are the behavior of that class. Then for a class is a collection of fixed number of components. We have different components that are made up of a class. So they are the different collection of these components are what we call a class. And the general syntax for a class is we have the modifier, we have the class, and you have the class identifier. That is, the class identifier is talking about the name that you want to use for that class. But the class we have in the middle is the reserved word. That class is a reserved word, or you say a keyword in Java. So that class is a keyword in Java. So the syntax is modifier, the class, then the class identifier. Then we have the opening curly brace, then we have the class members, then closed curly braces. The modifiers here, they are used to alter the behavior of that class. And I remember in our Perl class, we have been taught the different modifiers that we have. So the same way in Java, we have the public, we have the private, you can have protected, you can have static as a modifier. Then how does a class access the class members? The general syntax for that is reference variable name dot member name. You have the reference variable name dot member name. The class members here, the way you access the class members, it depends on where the object is located. The way the class members will access the object depends on where that object is located. For instance, if the object is created in the definition of a method of a class, then the object can both be public and private. That's if it's created in the definition of a method of a class. But if it is created elsewhere, for instance in the user program, that means the object can access only public members of that class. You get to understand this better as we go on. Then we're also going to be talking about class specification. Class specification. How does a class specify the property? Specify the property. How does it specify the method and the actions that it would work with? There's a syntax for this. A class can specify the properties and the behavior using this syntax. You have the public or abstract or use final, then you have the class keyword, then you have the class name, then extend object name or implement interface name. So this is how a class can be specified in Java. So in our next class, we are going to continue. We'll talk about the properties, the class methods, the types of methods, and we'll talk about the inner classes.